Good morning, children. This is Shivalsa speaking. In the previous video, we had a discussion on chapter 9, rational number. I gave you a brief idea about rational numbers, how rational numbers exist in mathematics, what are rational numbers, what kind of numbers can be expressed in form of rational numbers, what are the basic criteria of rational numbers. All these things we had discussed in previous video. Now in this particular video, we are children going to deal with some questions, question number 2, 3 and 4. As I wrote some questions on the copy that write 4 rational numbers in each of the following pattern. Before we go for such questions, I want you to go for the definition of rational number once again. Rational number is the number, short of a number, which can be expressed in form of P by Q, where denominator is non-zero. Means any number in fractional form can be expressed in form of fractional form can be expressed in form of rational number, but the only criteria is it should not have any denominator 0. 0 cannot be a denominator. In the place of denominator there should be no 0. That is only the basic criteria of rational number. So here in this particular exercise, we are going to deal with some questions in which some rational numbers are written, which looks like negative integers. It's form of like minus 3 by 5, minus 6 by 10, minus 9 by 15, minus 12 by 20. These are the rational numbers I wrote, which all are in negative form. No matters whether the numbers are negative or positive. All these numbers are rational numbers. Even 0 is also an example of a rational number, because 0 can be written in form of 0 by 1. 0 even can be expressed in form of 0 by 1. So naturally these numbers are a rational number. So here in this particular question number 2, the first question is minus 3 by 5 comma minus 6 by 10 comma minus 9 by 15 comma minus 12 by 20. Children, these numbers are in series. If you look at the pattern of these questions, you will be easily make out. You'll be able to make out that these numbers are in series. Minus 3 when it turns into minus 6. Minus 3 when it turns into minus 6 when we multiply it by 2. Means minus 3 into 2 minus 6, 5 into 2 10. Next, minus 3 into 3 minus 9, 5 into 3 15. Again, minus 3 into 4 12, 5 into 4 20. So after, what is the next number? 5. 5 into minus 3 means minus 3 into 5 and 5 into 5. Minus 3 into 5 is minus 15. By 5 5s are 25. Next, minus 3 by 5. After 5, what is the next number? 6. Minus 3 into 6 minus 18. 5 into 6 30. Next number, minus, as I was told to find only 4 numbers, so I got more 2 numbers. I need more 2 numbers from minus 3 by 5. Minus 3 by 5 into 7 into 7. Minus 3 into 7 is 21 and 5 into 7 is 35. Next number, minus 3 by 5 into 8 into 8. Minus 24 by 40. So 4 numbers I got from here, from minus 3 by 5. This way we can find our numbers. I wrote the number was minus 3 by 5, and all these numbers were in the relation. The relation was, it was started multiplied by 2. 2, it was multiplied by 3, it was multiplied by 4, then I took 5, 6, 7 and 8. As more numbers will be required, we can multiply the numbers right from as it was as it has started from 5. We can multiply with 6, we can multiply with 7, we can multiply with 8. In this way we can get an answer. Alright, what is the next number, children? The next number is minus 1 by 4. Let me write minus 1 by 4 comma minus 2 by 8 comma minus 3 by 12. So as here we can see, the numbers are in pattern. the numbers are in pattern. The numbers are minus 1 by 4, minus 1 into 2 is minus 2, 4 into 2, 8. Minus 1 into 3, minus 3, 4 into 3, 12. So after 3, what I'll take? 4. Minus 1 by 4 into 4 into 4. Minus 4 by 16. Next, minus 1 by 4 into 5 into 5. Minus 5 by 20. Minus 1 into 6 by 4 into 6. Minus 6 by 24. Next, I'll take 7 into 7. Minus 7 by 28. There are 4 numbers I got from this number series: minus 1 by 4, comma minus 2 by 8, comma minus 3 by 12. So this way, children, we can get an answer. So what I want you to go for the next sums your own. The next number is given minus 1 by 6, comma 2 by minus 12. Next number is minus 3 by minus 18, comma 4 by minus 24. These are really very easy to understand, and of course, if you have understood the things which I have explained right now, you can surely go for these sums. Next number is question number 3. Give 4 rational numbers are equivalent to minus 2 by 7. Children, I am given one rational number, that is minus 2 by 7. I have to find 4 rational numbers similar to minus 2 by 7. 4 rational numbers means equivalent, they're asking. So simply what I can do, I can multiply 2 by 2, 3 by 3, 4 by 4, 5 by 5. Easily. All these numbers will be equivalent to minus 2 by 7. The first number was minus 2 by 7. Next number I can take minus 2 by 7 into 2 into 2. It will be minus 4 by 40. Next number I can take minus 2 by 7 into 3 into 3. Minus 6 by 21. Next number I can take minus 2 by 7 into 4 into 4. It will be minus 8 by 28. Next number I can take minus 2 by 7 into 5 into 5, minus 10 by 35. So this way I can take 4 rational numbers equivalent to minus 2 by 7. So the equivalent fractions of minus 2 by 7 are minus 4 by 14, minus 6 by 21, minus 8 by 28, minus 10 by 35. All these numbers are equivalent to minus 2 by 7. These all numbers are equivalent to minus 2 by 7. Next number is 5 by minus 3. And I want some equivalent fractions of this number. What I'll do? 5 by minus 3 into 2 into 2. 10 by minus 6. Next number is 5 by minus 3 into 3 into 3. 15 by minus 9. Next is 5 by minus 3 into 4 into 4. 20 by minus 12. Next I'll take 5 by minus 3 into 5 into 5. 25 by minus 15. This is the process by which we can get 4 rational numbers, 5 rational numbers. No matters how many rational numbers they're asking, we can get uncountable number of rational numbers. As we know, there are no limit of rational numbers. Numbers are infinite. Numbers have got no limit. Similarly, rational numbers also have got no limit. There are uncountable number of rational numbers can be found between two given rational numbers or from a rational number. Uncountable number of rational numbers can be found. Okay. Next is what? 4 by 9. Next number is 4 by 9. And I want 4 rational numbers of 4 by 9. Okay, no problem. I'll write 4 by 9 into 2 into 2. Now here is a question, children. Why can't we take from 1 into 1? Because if I take 1 by 1, I mean multiplying 4 with 1, multiplying 9 with 1, it will be resulting same value. So no matters, I mean, there are no benefit of multiplying the numbers with 1 and 1. So it's better if you take more than one value, I mean more than one. So I started from 2. 4 2s are 8, 9 2s are 18, 4 by 9 into 3 into 3, 3 4s are 12, 3 9s are 21, 27, I'm sorry, slip of tongue. 4 by 9 into 4 is 16 by 36. Next number is 4 by 9 into 5, that is 20 by, here is 5 4s are 20 and 5 9s are 45. So in this way we can get rational numbers. So in the next part of this question is written that draw the number line and represent the following rational number numbers on it. Okay. Next question is 3 by 4. Rational number is given. I have to represent on 3 by 4. Yeah, it's 3 by 4. A rational number is given, that is 3 by 4, and I have to represent this number on number line. Okay. Children, very easy, just like the concept what we have done in the case of integers. Even in class 6 also we have learned how to represent a fraction on a number line. Same concept, only thing is what? We are using a word, we are using a term, rational number. In class 6, we dealt with the fractions keeping on number line. That is what we are doing, we are repeating over here in class 7, that is representing rational numbers on number line. The concept is just exactly same. That is 3 by 4. So what I'm going to do right now, I'll draw a line. This is 0. 1, 2, minus 1, minus 2. Children, 3 by 4 is a positive value. Of course, yeah, there are no negative signs in front of it. It's a positive value. Alright. 3 by 4 is a proper fraction. It means that it will come between 0 and 1. Every proper fraction in the world comes between 0 and 1. As it is a positive number, so it will come between 0 and plus 1. If this would have been, suppose, minus 3 by 4, it could have been between 0 and minus 1. So here this number is 3 by 4, it comes between 0 and plus 1. 3 by 4 is a proper fraction. Numerator is smaller than denominator. So this is a proper fraction. And this fraction will come between 0 and 1. No matters. So here the denominator is 4. So I'm going to make 4 equal parts between 0 and 1. 1 part, 2 parts, 3 parts and 4 parts. There are 4 equal parts. As the denominator is 4, I'll make 4 equal parts. So the first number is 1 by 4. Next number is 2 by 4. Third number is 3 by 4. This number is 3 by 4. Okay, children, this way we get an answer. Next fraction was, that is the rational number, minus 5 by 8. So that is also proper, and it's as it's holding a negative sign, it will come between 0 and minus 1. 0 and minus 1, you have to make 8 equal parts. There are 8 equal parts. First part is minus 1 by 8, minus 2 by 8, minus 3 by 8, minus 4 by 8, minus 5 by 8. This is minus 5 by 8. So this way, children, we'll be practicing these sums. I hope you understood. This way we'll be practicing a similar pattern of questions from the exercises, and once we are over with this particular chapter, we'll go for new things. So this rational numbers concept is really very important, and these things will surely come in your exam. So I believe that you all have understood, and you'll be practicing these things at home. Thank you, children.